In this video, I want to have a look at the product rule. So the product rule for differentiation is used when we've got a function that's made up of two smaller functions multiplied together. So on your formula sheet, the product rule looks like this. So if we've got y equals uv, where u and v are both functions of x, then dy dx is going to be equal to u times the derivative of v plus v times the derivative of x. So let's have a look at an example. So our first example says we've got y equals 3x minus 1 and x minus 4. So what we're going to do off to the side, we're going to call this first one u and this second function v. So we're going to write u equals 3x minus 1 and v equals x minus 4. Then just under that, we're going to find du dx and we're going to find dv dx. So then we can plug it back into this formula. So differentiating this function with respect to x would give us 3, and differentiating this one would give us 1. So now we can substitute into our formula. So dy dx is going to be equal to u times dv dx. So we've got u times dv dx. So 1 times this will just give us that 3x minus 1. And we're going to plus v, so this term here, times du dx, so 3. So we're going to have plus 3 outside of x minus 4. So we can simplify that. I'm going to expand this one out. So we'll have 3x minus 1 plus 3x minus 12. So simplifying that again, collecting like terms, we'd have 6x minus 13. So we could have also done this by expanding these brackets out and then differentiating normally, and we would get the same result. But you can imagine that if these were more complex functions, then it would be more difficult to do that. Our second example, we've got y equals x to the power of 4 and then x plus 2 to the power of 5. So we're going to write u equals x to the 4 and y equals x plus 2 to the power of 5. And then we're going to differentiate both of those with respect to x. So du dx would give us 4x cubed. And, sorry, I meant to put a v there, not a y. And dv dx would give us. Now this relates back to the chain rule that we were doing last lesson in the last video. So we'll bring that 5 down the front. So differentiating the outside, leave the inside. And then multiply by the derivative of the inside, which is just 1. So for this one, that because it ends up being a times 1, we can kind of just ignore that bit because it doesn't change it. So now we've got our derivatives and we can substitute back into this formula here. So we're going to have dy dx is equal to u times dv dx, so x to the power of 4, times this whole thing here, so times 5. I'm going to run out of room here. I'm going to move all of this down. So dy dx equals x to the power of 4 times 5 outside of x plus 2 to the power of 4, and then plus v times du dx. So v is this and du dx is this. It doesn't matter which order you write these in. I'm actually going to write this one first. So 4x cubed times x plus 2 to the power of 5. So simplifying that down a little bit, we've got 5x to the power of 4 outside of x plus 2 to the power of 4, plus 4x cubed x plus 2 to the power of 5. Now this is still looking a bit messy, but hopefully you can see that we've got some common factors in there. So we've got x's here, this one's to the power of 4 and this one's to the power of 3, but that's okay. And we've also got this bracket here, this x plus 2 in brackets. And again, our powers are different, but that's all right. What we're going to do is we're going to pull them out as common factors and just pull out the the highest power that's common in both of them. So we can pull out an x cubed because there's at least an x cubed in both of those. And we can pull out an x plus 2 to the power of 4 because there's at least that in both of them. So what that's going to leave us with here is a 5x because we pulled out x cubed, so there's just one x left there. And we've pulled out this whole bracket, so we're just left with 5x from there. And in this one, we've got our 4. Our x cubed has been pulled out, But we are left with this x plus 2 because it's a power of 5 there and we've only pulled out to the power of 4. So this algebra is just getting a little bit more complicated. Oh, that's a cubed. X plus 2 to the power of 4. But if we expand this one out now, we're going to have 5x plus 4x plus 8. So our final answer, we're going to have x cubed outside of x plus 2 to the power of 4 outside of 9x plus 8. Okay, we've got one last example here. So we've got y equals x squared plus 8, 4x minus 2 cubed. So we're going to let u equal that x squared plus 8, that's that first bracket, and v equal 4x minus 2, all cubed. So we'll differentiate both of those with respect to x. So this one would give us just 2x, and dv dx. Again, we're going to have to use the chain rule. So we'll have 3 outside of 4x minus 2 squared times 4, because we've differentiated the inside. And simplifying that, we'll have 12 outside of 4x minus 2 squared. Now we can sub all that in. So dy dx is going to equal u times dv dx. We're going to have that x squared plus 8 times 12 outside of 4x minus 2 squared. And we're going to have plus v times du dx. So we've got 4x minus 2 cubed times 2x. Okay, so looking at what we've got in common in there, both our terms have this here, this bracket, so we can pull out a 4x minus 2 squared. And they also have a 2 here, 2 and a 12, so we can pull out a common factor of 2. So we can have 2 outside of 4x minus 2 squared, outside of, and here we're going to have a 6 outside of this bracket left, so 6x squared plus 8. And over here, so we're going to have plus, we're going to be left with our x outside of this bracket here, so 4x minus 2. And that's because it's a cubed there and we only pulled out a squared. So if we expand and simplify that bracket that's inside there, we've got 2 outside 4x minus 2 squared, we'd have 6x squared plus 48 plus 4x squared minus 2x. And the last one, just collecting those like x squared terms, we'd have 2 outside of 4x minus 2 squared, 10x squared minus 2x plus 48. All right, so those are 3 examples of differentiating with the product rule.